That is going to take just 1 second to set this up. So that is wonderful. And we have students joining in, so they can. Do you hear me okay?
Yes.
Yes, I can hear
Okay.
you.
Perfect. Welcome, everyone. It's a pleasure to join together this evening for the session about robotics, our favorite subject in the robotics program First Tech Challenge Romania, run by our NGO Nație prin Educație, based here in Romania. We are joined today by Gianpaolo Gulletta. Welcome.
Thank you.
And by Eugenia Covington, our partners from Lecturers Without Borders. In our participants here, we have mentors, teachers, and students from the robotics program. Throughout the session, please use the chat function if you want to ask questions. I advise everyone to turn on their cameras so we can see each other. And after the presentation, we will have a Q&A where we can have a dialogue and ask questions. So without further ado, I want to first present our partner, Eugenia, from Lecturers Without Borders, who throughout the year 2020 has always been so kind and invited our students to webinars. And Eugenia hosted a webinar for us about viruses, and that was very interesting. Thank you. Welcome.
Hi.
And if you can please share with us a little bit about you and the Lecturers Without Borders.
Great, thank you. Yes, so my name is Eugenia. I am originally from Argentina. I'm based in Paris. And I am the scientist coordinator of Lecturers Without Borders. Lecturers Without Borders is a project that started in around the year 2017 and was launched by a group of international scientists. All of us are doing science on the side, and this is an organization that we started with the idea of connecting scientists that are traveling for conferences or on private occasions, like when they go on holidays. We connect them with high schools or educational organizations to organize free outreach lectures. The idea is to bring science to schools directly from the scientist, and ideally to introduce schools to topics that normally they would not cover in their usual curriculum. So the idea is if we have a lecturer that is, I don't know, a mathematician going to a school that normally would not cover that particular topic, then the kids are also introduced to a different topic. So from both sides, there's, we think, a win-win situation, because we have scientists that have the opportunity to do outreach activities that many scientists are very interested in, and sometimes finding a place to do it is hard. And well, as the coordinator of scientists in Lecturers Without Borders, when Gabriela told me about this idea of science dialogues, I contacted, as the coordinator, the scientists that we found in our database of scientists that were related to the topic of robotics. And Gianpaolo is one of those scientists. So I would like now to give the word to Gianpaolo to introduce himself. Or I don't know if Gabriela, you want to introduce him.
Please, this is perfect. You have the floor, Gianpaolo.
Okay, thank you. Thank you very much for this invitation. It's a pleasure, first of all. Thank you to all the organizers. Yes, basically, what I do for my PhD, I work basically with anthropomorphic robots. My research interests are related to neuroscience, to bio-inspired robotics. So what I try to do is to get inspired from the psychological aspect of human movements, to try to encode some regularities that humans have, and then I transfer those regularities into a mechanical device, basically. I'm passionate about, so my PhD is basically interdisciplinary. So what I read about the psychological aspect of movements, of arm movements in particular, and I run experiments with an anthropomorphic device with 2 arms and 2 robotic hands. The main motivation behind human-like motion in robots can be found in industries, in schools, anywhere a smart device can interact with people, can collaborate with the human partners, human observers. The main point of having human-like motion is about predictability of the movements. So when robots and humans interact together, it's what is necessary, especially in joint tasks. What is necessary is a successful non-verbal communication to have the accomplishment of a task. So imagine transporting a table. So and so this is something humans normally do without talking, basically. So because we can basically we can infer what our partner is about to do. So when our partner is a robot, the robot needs to move like humans do, basically. So my main research question was to understand what are the human patterns in arm motion, human arm motion, and how arm motion is related to the motion of the fingers. So, for example, during grasping, during prehension. So this needs to be replicated in a device which is basically which has an anthropomorphic shape. So a human partner can predict, given a task, can predict what the robot is going to do. So, and we don't want to let him down. So we want to have a smart agent acting in a human-like way. This is fundamental in smart industries. This is fundamental, for example, for rehabilitation, if we talk about wearable robots. So if we talk about smart exoskeletons. If we want, for example, another field of application is an intelligent prosthesis. If we, for example, if an upper limb is missing. So many field of application, we can have many application in this sense. Okay, so I would like to say that. So first of all, I had to identify what these human regularities. So if you have questions, you can stop in anytime. So I would like to be this to be a dialogue. So if you feel like you have any comments, please, if there is something you don't understand, so it's okay. I won't wait the QA section if you have questions. Okay. So basically, I had to understand these patterns. There are some regularities when, for example, humans need to avoid obstacles during grasping, during reaching, in general, in movement. So there are kinematics. There are kinematic variables the robot has to respect during the motion, and this kinematic. So basically, the human likeness of a robot can be quantified. It's not only because the big mistake is to take to understand human likeness as a qualitative metric, but it is not actually. So we have quantitative measures of human likeness, luckily, so I can measure it. So, for example, if you want, I can show you some video I have prepared for you. So I can share the screen.
Yes, that would be wonderful.
Okay. Okay. Can you see my screen?
Not yet.
Not yet.
No. So you have the option of.
Yes.
Let me see. Maybe now. Okay. No, we
What
see
about
it.
now?
Yes.
Okay. So in this task, basically, you will see an anthropomorphic robot serving a drink, which is something we dream about probably. And you see this robot is has an anthropomorphic shape. He has to grasp this bottle, avoiding avoid the black bottle, which is an obstacle, and serve some orange juice. So when you look at the robot, you can infer some the movement you will expect from this robot. And so the task is successful, and the robot goes back to his initial position. Collisions are avoided, and so it's basically, so you see the robot is moving slowly for safety reasons, but it can be faster. It can be very fast. So what we have now is another video of the same task, but basically the robot is moving in a different way. You will see, for example, this is a motion planner we have in literature, in robotics. So the task can be accomplished quite easily. The black bottle can be avoided, and okay, so he's going to finish the task right now. So as you can see, there are many solutions. These solutions are can be found by exploiting the intrinsic redundancy of the human arm. So this arm is a robotic arm. It has 7 degrees of freedom. And so for the same, like a human arm, for the same problem, we have different solutions. What we want the human-like solution. Okay. So could you, okay, so I would like to stop sharing, I don't know how. Yep.
It should be from the same share screen. Stop share screen. Okay. Yes. Now we see you.
Okay. Sorry. I don't know if you could feel the difference between the two movements. So the first one was human-like, the second one was not. And the reason behind it is about transferring human-like kinematic variables to the robot. And the reason we can have two different solutions is that we can use the redundancy of the arm in a different way. So that is pretty much everything. I hope it was interesting, and yeah, I'm open to questions.
Yes, we have some participants here. We're an intimate group of 12. So I invite everyone to turn on their cameras so we can see each other and have a dialogue. Maybe let's start off by presenting ourselves, because we are an intimate group, and maybe each and every one of the students, and I see Professor Sabine Montano as well here, maybe everyone will like to introduce a little bit about themselves, their robotics team, and then jump to question. So I'm going to invite everyone in the order that I see here on the screen. So the first one for me is Adia. Welcome. Hi.
Hi. Well, I'm Adia. I'm from Iași, Romania, and I come from the robotics team Silas Peppers, which is a great team in my personal belief. And I don't have a question right now. I'm still thinking, but I'll come back with a question, I promise.
Yes, that is perfect. Professor Montano, welcome.
Nice to see everybody.
Nice to see you as well.
Okay.
Welcome.
I have no question. Maybe later.
Maybe later. Yes, of course. That is perfect. I have Andrea here from row 139. Hi, Andrea.
Oh, sorry, I had my microphone. Yeah, I'm at my grandma's place, so that's why I'm wearing a mask.
It's okay. We're used to it.
Yeah. I'm Andrea. I'm from robotics team TechnoZ from Romania, and I really enjoy the talk about robotics, especially since I think we're all extremely passionate about this file here. I honestly don't have a question right now also because I'm still processing everything. I'm quite slow on that. But I think it's amazing we can meet like this and have those talks with scientists because it really helps us broaden our horizons, and it's amazing to have this opportunity.
Maybe, Andrea, you can share a little bit about the robots that you are building. So Gianpaolo has an idea of the type of robots.
Yeah, sure. Every year we have a different theme for our robots. And this year we have to throw some rings in a target. It's actually really interesting because sometimes it implies more on the programming side. But this year, I think it's more about the physics part of it. So it really helps us try to do our best in every field of STEM because we don't only concentrate on one of it. And even though we have different departments in the team, I think that everyone could easily do each and one of the jobs we have in a team. Yeah, I'm sorry. But yeah, last year we had to build a tower. So we actually had to grab things just like the robot in the previous video. So we also have to study the movement of the robot in general, especially for the autonomous period where the robot moves itself, it is not driven by the drivers. So yeah, I hope I haven't missed anything.
Thank you. That is perfect. I see Mihna. Hi, Mihna.
Hello.
Hi.
I'm from Măgureni. The team is from Câmpina, Prahova. I'm come from Team Undefined. And I'm the team leader.
Wonderful.
This,
oh, sorry. Yes, please go ahead.
I want to say that this year we didn't really start building the robot yet, but our robot will be the basic type this year. Nothing really special, but we'll try to do our best.
Wonderful. Good luck. Mircea, hi.
Hello, my name is Mircea and I'm a member of Esența Robotics team. The team is from Beclan, a small town from Romania. And I'd like to ask you, what do you use to measure as precise as you can the kinematic variables?
The kinematic variables, you mean? Sorry, I didn't hear you very well.
What do you use to measure as precisely as you can the kinematic variables?
Okay, so I communicate with the robot through ROS, the robotic operative systems. What I measure from the robot is the position as velocity and acceleration of the joints, of the end effector, and of the fingers. And I compare the profile, the kinematic profile, especially of velocity, acceleration, and jerk, which is the third time derivative of position, with human regularities. So we have, so in this way, I can compare what I obtain from I can compare what I obtained from the robot with what has been studied with the humans. I don't know. I hope I've answered the questions.
Yes, thank you.
Thank you. Denisa, welcome.
Hi, I'm quite sorry because I can't turn my camera off. Thank you for the lecture. It was really interesting. I'm from team Code Warriors in Mediaș, a town from Romania, and I actually wanted to participate in this webinar because I'm usually on the marketing side of the robotic program. So it's really interesting for me to understand more about what my colleagues usually do. So thank you.
That is wonderful, Denisa. Yes, Gianpaolo, it's something quite special about the robotics team. They act as a startup, so you have a technical partner of the team that builds the robots and does programming and 3D, but you have also in the team members who do communication and marketing and run events. So it's good we have here technical and non-technical members. Professor Dan from row 126, welcome. You're okay.
Hello.
Now yes. Hi.
Greetings. We want to know which type of sensor use for robotic skeleton.
Which type? Sorry, which type of?
Which type of sensors? Which type of sensors?
Okay, okay. So the robot is the brand of the robot is Amtech. So what I have, what I measure from the Amtech, there are encoders in each joint, so I can measure basically position. I usually measure position, and from position I derive velocity and acceleration, but I need to use a filter, of course, because otherwise I have noise. And so what I tested my software with this robot first, because I was interested in testing it with anthropomorphic devices, but I also tested with the robot Sawyer from Rethink Robotics, and now I'm testing it with a 6 degree of freedom manipulator from Universal Robots. So with these more recent robots, life is easier somehow, but yeah, basically what I do, I measure what they give me is position, and I try to rely only on position and derive the rest of the information.
Okay, thanks.
Thank you.
Thank you. Can you share us a little bit about the projects that you are doing right now? Let's say who are work in progress for you.
In this moment, we study a lot of method, let's say, to achieve the targets, the result. And for this years, we have a challenge, let's say, to drop the yellow pieces, and yes. This could be a tough part of the robots. And here we must decide in which way we can do that, because for our, let's say, research for this season, we must take in consideration the time and the speed, and depend of the strategy what you really want to do. You can use one strategy or other, and so on. But it is a lot of place for any kind of the solution. And I expect to see a lot of solution, interesting solution, and funny and something like that. That was a really nice part.
Yes, to maybe check the award for innovation within the
Yes, for sure.
competition. Yes, within the competition we have awards that really focus on innovation, design, or the Think Award that tells us that the team really had a good strategy, and the science behind the strategy is highlighted in the robot and in their engineering notebook. Gianpaolo, I would be curious to learn from you and from your work right now. What are you most passionate about or excited about in terms of robotics?
Yeah, this is the key question. This is this is about motivation. What I really like about robotics is that what I have understood during these years of research is that you can discover about yourself, you can discover about humans, how humans work through a device. So what I try is basically to replicate what is working in humans into non-lifelike device. So it is not so in this process you understand more about our kind, so more how our brain works. This is fascinating. This was not part of my background, because my background is about information technology, electronics, and so this is really fascinating, because you can replicate these processes, and it works. So, and when it works is amazing. So it's yeah.
Yes, we hear this a lot from the students, especially from the programmers. When we ask them, what are you most passionate about? They say, when the programming I do on my computer transforms into something that is alive and I see it moves. Welcome, Professor Stanculescu, as well. Hi. You're on mute. We cannot hear you. If you'd like to say a few words. Hi.
Yes.
Wonderful to have you here as well. Does anyone have other questions, or maybe regarding the challenge that you have this year for the building of the robot, and would like some advice since we are talking about robots, or any other question, of course?
I have a question. It's okay
Yes.
now?
Yes.
Okay, I appreciate the robot made maybe by Gianpaolo, and I have with attention in the robot science, and I saw that many robots are unprecise in movement. From are coming the limitation in robotics, from sensor, from soft, from program, from hardware. Can you tell me and tell us something about in robotics? Thank you.
So as far as understood, the question is about accuracy in motion. It's about how a movement, what is the level of precision in placing the end effector in the workspace. Is that correct? Yes. Okay. So the videos I showed the movements were executed in an open loop. So when I want some precisely place the end effector in the workspace, I use a closed loop controller. So I correct the execution of the commands on a joint level through the visual. I use the visual system to understand where the target is, if the target has moved, if the end effector is in the right place where it's supposed to be. In an open loop, without feedback, I cannot correct the movement, basically. The videos you have seen, the execution of the commands are in an open loop. So precision was not the objective of my experiment. So in my more recently in my experiment, I also introduced a closed loop controller that can also replicate somehow to a certain extent the human likeness that I want to be there, and to maintain also maintain a level of precision that is required by the task. For example, a task of assembling two objects, for example, like a peg in a hole, so which requires precision. So it can be done, but I need a visual feedback for that. So this is what I have implemented. I don't know if I fully answered the question. I hope yes.
Okay, yeah. Thank you. Yeah, I understand.
I have a question for you regarding the future. What's the future for robotics, in your opinion? What can we expect in the future in terms of robots and systems that are intelligent?
Is it a question for me?
Yes, please.
Okay. Okay. Wow. Okay. So I can tell what I can tell you is what I read recently is a paper describing the society 5.0. So according to this paper, I would like to mention the authors, but at the moment I don't remember the authors. Maybe I will email them after.
Yes,
that.
please, and I will share it.
So there is it's a study about our society. We are, according to the authors, we are currently in a society 4.0, information societies, where robots are at this moment are passive tools. We use robots to do something, basically something we don't want to do. So in the next future, in the next society, robots will be more intelligent, will be able to take action, basically, make decisions. And but like, for example, many devices do in our environment, for example, our smartphone, our smart TV, our computers, they make a decision. But the difference between these devices and a robot is that the robot can physically interact in our space with arms and legs and wheels. So, so there is the impact is very different. So the interesting part is that about this new society is that the robot will be, of course, this is an analysis, is an opinion. Robots will be smart agents we have to interact with. They need to be designed in a human-centered way, because they will be more and more invasive. So they need to carefully applicate the Asimov laws. So, and interact safely and in a smart way with humans. So the main purpose of I believe the main purpose of the robots of the futures is not to automate any task, is not to replace humans, is to augment the capabilities of humans. So help humans in doing something, in joint tasks, replace them in dangerous environments, but at the end, teleoperational tasks, for example, but at the end is going to be about augmentation instead of automation, like it has been nowadays, for example. So I really agree with this vision. I don't think robots will take over us. If this is the question, I don't know, but yeah.
Professor Sanculescu wrote to us that maybe the author of the research paper is Michel Hopft, if I pronounce it correctly. It's in the chat. Maybe it sounds familiar to you.
If you give me just
yes,
1 minute,
thank you.
I can say that. Yeah.
In the meantime, if you have other questions.
Eu nu o să mă descurc așa de bine cu engleza.
Oh, it's perfect. Pot să traduc eu. E perfect.
Bine.
So I will translate to you, Gianpaolo. Vă rog.
Yeah, okay.
Tocmai citesc Noah Yuval Harari, 21 de lecții pentru secolul 21. Și am citit și celelalte, Sapiens și Homo Deus. Și el are viziune foarte detaliată a istoriei umanității de la început și în viitor. Și el spune la un moment dat, poate exact același lucru, că roboții vor augmenta capacitățile noastre, dar în mare parte ne vor înlocui în activitățile acestea repetitive și foarte, să zicem, repetitive, să zicem, da? În care ne vor lua locul și datorită forței și uneori datorită rapidității cu care execută anumite lucruri. Traduci până aici sau?
Da, scriu în chat, așa că puteți continua. Vă rog.
Și, dar la un moment dat, am aici un mic neroboțel, nepoțelul.
Da. A little robot kid.
Hey! Care vrea să povestească niște lucruri. Dar zice la un moment dat autorul, destul de important, zice că s-ar putea la un moment dat să ne înlocuiască în foarte multe alte lucruri, pentru că fac lucrurile acestea cu foarte mare precizie și pentru că de fapt defin o rețea, nu numai un robot, ci o rețea mondială care s-ar putea să lucreze în multe domenii și unele care par mai creative mult mai bine decât noi.
Doar o secundă. Gianpaolo, in the meantime, I will write in the chat. So I wrote a little part of it, so if you can follow us there. Vă rog, profesor.
Așa, și zice, s-ar putea ca la un moment dat noi să fim cei care nu putem ține pasul cu, să zicem, să ne găsim alte activități în care roboții să nu ne înlocuiască. Pentru că, în mare parte, în multe din domenii ne vor înlocui.
Bunica pleacă, l-am găsit.
Bunica pleacă, da, trebuie să merg, da. Nu știu
so
dacă...
Professor Sanculescu has some raises a very important question about humans at some point, according to the historian Harari, that we run the risk of not keeping pace with the robots. And yes, please, vă rog, continuați, doamnă profesor.
Mă gândeam doar și la ceea ce spune de inteligența artificială. Și la, da, te duci până la bunica. Și tocmai asta zice că inteligența artificială și rețeaua de aceasta mare mondială s-ar putea să ne înlocuiască nu pentru că vor ei, ci pentru că asta se va întâmpla la un moment dat și vom fi neglijați. Deci va fi o înlocuire prin faptul că vom deveni nesemnificativi, să zicem, ceea ce se întâmplă în continuare.
Da, and we run the risk of not only maybe not keeping pace with the robots, but just to be some pieces, let's say, in the system, in the network, and lose our importance and feel, in a way, insignificant, maybe in terms of our contribution or our ability to do things compared with robots. I-am transmis lucrurile acestea. Aveți cumva o întrebare sau...
Nu,
okay,
dacă...
O opinie.
Da, mă gândeam dacă dânsul este de acord cu această idee, că am înțeles ideea asta care a spus-o dânsul, dar dusă mai departe s-ar putea, nu știu, s-ar putea să aibă dreptate Harari.
Da, absolut. So this is a possible scenario that Harari is giving in his books, Lessons for the 21st Centuries and Sapiens, which is an interesting, vision that he has. What's your opinion about this? About maybe people getting lost in an intelligent network, losing their importance, and not being able to keep pace with the robots.
Okay. May I?
Yes, please.
Okay. So first of all, I would like to mention the paper I was talking about. The author is Matthew E. Gladden, and the title is "Who Will Be the Members of Society 5.0 Towards an Anthropology of Technologically Post-Humanized Future Societies."
If you can at some point share it in the chat as a link or...
Oh yeah, sure.
Thank you.
Sure. Yes. I will try, because I don't know for which reason this chat is not working properly right now.
Oh, it's okay. Yeah. I will share it afterwards. If you can share it in the email, it's perfect. Sure. I will share it. Yes, thank you.
Okay. Secondly, I would like to say that I haven't read the book. It's a very popular book. I would like to read it. Then it is a very complicated question. It deserves time. And I would like also to say that, of course, nobody knows the future. So this is only my opinion. I think basically a technology, there is no good and no bad technology. This is, in my opinion, how you use it. Of course, can be powerful. Okay. So, for example, when you even artificial intelligence, robots can be able to learn faster and better than any humans. So this is true. But this is also what is also true is that algorithms are programmed in a way with an objective function to maximize objective functions. So those functions are selected by humans. So what a device is going to learn is selected by the programmer. And the robot can learn it very, very well, very, very good. It can be fast, it can play chess, it can learn basically almost everything you want to. And this is, I understand this can be somehow scaring, but I don't think there will be a full replacement of the humankind. That is something, I don't think that human would be useless at one point. Also because I don't see an enemy to fight. I don't know how to explain. In my opinion, the technology robotics in particular will be more human-centered. So you will be, we as humans, we can be, we are the terminal of some new services. So we can have, we can share, we can use this artificial intelligence if we want. And but the point is behind this big machine, you have maintainers, you have programmers, there are policies. So, and these things need to be, there is an ethical problem. There's a big ethical problem. So, but this is not about the technology, in my opinion. This is about politics. So so we have big data, okay? It's up to us. We want to decide what we want to do with this data, okay? Again, this is my opinion. I don't have very good answers to this complex question. We can talk hours, but it is an interesting ethical problem.
O să mai pun o întrebare.
Sigur, vă rog.
Atunci când a apărut robotul Sofia.
Sofia, yeah.
Da?
O să fac o traducere pe măsură ce vorbiți.
Da.
So it's about the Sophia robot.
Yeah, Sophia robot is a...
Care a fost reacția ca specialist la acea situație?
Ce întrebare bună.
Pentru că mi s-a părut că cineva a vrut să facă o nouă problemă în mintea poate a oamenilor de rând sau a multor oameni care nu cunosc domeniul.
Da.
Și mă întreb, era vorba de politică la un moment dat și de ce au făcut-o, că n-am înțeles niciodată de ce au dat cetățenie, de ce l-au făcut mai important decât femeile din țara aia care sunt considerate animale și așa mai departe. N-am înțeles de ce, adică am înțeles de ce, pentru că există o proastă gândire, dar aia e altă treabă.
Să traduc un pic.
Da.
So Professor Stănculescu is talking about the moment when Sophia the robot was launched on the market, let's say. And in his opinion, it was a move to shock people who were already having questions about robots. And suddenly they found out this is a robot that looks like a person and even has a citizenship. And like Professor Stănculescu said, that in a country where women actually don't have maybe a lot of rights. Vă rog, continuați.
Da, și asta era întrebarea, care a fost reacția? Pentru că reacția mea știu care a fost și mi s-a părut un mare fake și un gest de, iară, desconsiderare a oamenilor și prostirea oamenilor.
Înțeleg. So the question of Professor Stănculescu is, what was your reaction when you saw the robot?
Oh, well, of course, I was impressed. I mean, the Sophia robot is so. I mean, as an engineer, when I see robots, I try to understand how they work. Okay, so and when I struggle with that, so I think, wow, I'm impressed, and it's very it's impressive. I mean, basically, the technology, the level of perfection engineers have reached with the Sophia robot is basically simply amazing. Yeah, but again, as you mentioned, there is a political problem, ethical problem. So a device can have a citizenship, and women don't have rights. So it's in my opinion, it is not again, it is not about the technology. The two things cannot be mixed up. They are two different problems. We cannot compare them, in my opinion. So we have a problem with in politics with women, and so that needs to be solved. And at the same time, we have new technologies rising up, and I don't see the relationship, honestly. And what I'm saying is that it's like saying, okay, we are going to the moon, we are going to Mars, but there are many people starving on planet Earth. So these two problems are different, so cannot be compared, in my opinion. So yeah, but this is just my opinion. It's not about the technology itself. It's how you use it, how you program it, what is the impact? The impact can be good, it can be bad, but it's up to us. In my opinion, at the end, there is the humankind. This is my modest opinion. But thank you for the interesting questions. Yeah.
Așa cum a spus Gianpaolo, niciodată nu, adică problemele sunt separate, dar oamenii le vor vedea împreună întotdeauna, pentru că asta este modul în care poate gândim. Noi ne vedem totdeauna comparați cu ceva și dați deoparte sau ridicați în slăv sau dați deoparte sau ridicați în slăv. Deci nu ne vedem separat de problemele din jurul nostru. Pentru că de-aia totdeauna și mașina automată, adică mașina electrică și mașina asta robotică, care va fi condusă singură, creează o problemă socială, cu toate că este un ajutor care ne va fi de ajutor să facem multe alte lucruri. Dar totdeauna ne vom compara, chiar dacă vrem sau chiar dacă nu vrem. Părerea mea este că asta se va întâmpla totdeauna. Sunt două lucruri diferite, dar unul afectează pe celălalt.
So Professor Sanculescu, he's expressing the idea that technology and humans are interconnected, and it's hard for people to see technology separated from their life and from the impact that technology has. So people from this point of view, if we're talking about cars without a driver and automated systems, people automatically think, how is this going to affect me? Or how am I compared to this robot? If we talk about, let's say, women comparing themselves with Sophia, the robot. So it's in human nature to compare to the technology and to not see the issues being separate. Are there other questions? If not, we are... I see something in the chat. So Professor Montano is asking us, what is your opinion about unmaterial mediums? So mediums who don't have substance of stocking information. So unmaterial mediums.
Yes.
Can you give us an example?
Maybe other kind of space for stocking for the information.
Virtual mediums, or?
Yeah, I'm afraid I'm not.
Medium, like a medium for information, unmaterial.
Like a cloud?
Maybe. No. Cloud is material medium.
Yeah, you have a server.
Yes,
something
true.
like something which is unseen, like a spiritual medium.
Okay. Well, I don't have.
Your opinion. You believe that? is the possibility to exist in next future this kind of medium for information?
Well, I'm
I think
afraid I
we're
don't have a
talking
good.
about Interstellar, you know? It
Ah,
makes me think of the movie.
no, not movie. For moment, is not movie.
Well, I'm afraid that it is an interesting topic, but I don't have a good answer. I don't know anything about this, but I will be happy to learn more about that because sounds interesting. I'm sorry, but I don't have a good answer for that.
I have this question because in my opinion, the limit is in robotics in every area is a real limit, and the next level will be when the humanity will pass over limit. Limit exists, will pass over. Limit exists, will pass over. But in next future, uh, the space, the media, the medium for information, in my opinion, that will be other kind of media, of medium. In this moment, uh, we 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 have the information on materials, okay, on materials, but in future will be other kind, other
Yeah,
kind.
maybe. Yeah,
That will be a real step and high step in stocking the information.
yeah. I will be happy to read more about this topic. Thank you.
Thank you. I thank you.
That's a very interesting topic. And since we are close to our end, I was wondering, Gianpaolo, if you would like to share with the students maybe your opinion about jobs of the future, since they are studying robotics and maybe
Yeah.
they are interested in this field. What would be your advice to them?
Oh, it's a responsibility. It's no. The job of the future about in robotics. I mean,
Yes.
So I don't believe that in the near future maybe some jobs will be replaced, but in the long term future, most of the job would be will change in a different way. So maybe we can have devices able to paint. We can have devices. Actually, maybe there is some robot programmed to paint, but in a more creative way. I mean, yeah. What I think is that many ordinary jobs will change and will introduce interaction with some smart device, robotic device. What I can suggest in terms of tools, what I find in terms of programming skills, Python and C++ are the main are mandatory basically in terms of programming. Also, what I can suggest is Java in real-time applications again. So programming again is a central topic, and I would suggest using Linux environment for any. I mean, Windows is good as well, but Linux. I'm a fan of open source software, so I like Linux. I like working on Linux. You can find almost everything nowadays. Yeah, and for example, when you, in terms of electronics, you can develop skills on Arduinos, Raspberry Pi. There are the very popular electronic boards. But it would be nice to learn some skills on designing electronic schematics and PCB prototyping. I know I'm being very technical now, but I hope some student can find this information useful.
Thank you. Yes, it is much appreciated, I'm sure.
That's it.
Well, thank you very much. It's been just a wonderful session, and I love the intimate group. It gave us a chance to know each other, to ask questions. Thank you so much, Gianpaolo, for sharing us your, I would not say work, I would say passion.
Thank you very much to you.
And all the best to you with all of your projects. And I wish you a fantastic end of 2020, quite a challenging year.
Yeah. Yes.
But we move ahead, and I am excited in terms of robotics to see what the future holds for us. And thank you everyone for being here this evening, and see you soon. We have a winter camp with other sessions as well. Next week we'll have another science dialogue like this one, and until the end of December we will continue with this series. So see you there. Thank you so much, Gianpaolo.
Thank you for having me.
Thank you. Goodbye everyone.
Bye.
Bye.
Bye.